Hi, my name is Dr. Elaissa Hardy, and today I'm going to talk about Hemonauts, a digital learning game to increase STEM learning and disease literacy in chronically ill children. I have two slide decks for you today. This first one is the research side and is about 30 minutes long, and then there's a second slide deck that just plays the game and is a game walkthrough for you, and that's roughly around 20 minutes. If we were in person, I would have the tablets and let you guys play the game, and then we could talk about it. Obviously, we're in this virtual space, so that's why we have the two decks. And since there isn't a Q&A, please feel free to email me with any questions, or if you want any of this data or the questionnaires, I'm definitely willing to collaborate and share the information with you. So my email is on this first slide. Just to give you some background, you may have recognized me from previous conferences where I talk about my research group, BME Health Reach, which is an educational enrichment program to motivate and spark an interest in STEM, STEM being science, technology, engineering, and math, through our hands-on interactive activities that are based in medical experiences and human physiology. The program is implemented by Georgia Tech biomedical undergraduate students. College kids are near peer age group, and the patients just think they're amazing. So we want to take advantage of that. And then from the Georgia Tech side, I teach a course at Georgia Tech to help prepare the undergrad students to work with the patients and then students within our community. I have our graphic here, which kind of shows what we do. So we have our suite of medically inspired STEM activities, and we do them in the hospital and then in the greater Atlanta community, and it provides educational value for the patients as well as meaningful relationship building and um, strong relationships for the Georgia Tech students. And many of them are pre-med, so it helps give them a better experience of the hospital as opposed to typical volunteering experiences. We're always making new activities. We show our cell fortune teller and our fidget spinner, and designing new activities following the national and local academic standards. You may have seen our blood jar before. I've done it at the previous meetings. It's a plastic jar and they add beads to represent what's happening in your blood. And we're just designed to augment the hospital school programs. But the question always remains is, can we turn this into something digital? And probably more prevalent today because of being in the pandemic and everything is digital or virtual. So we were asked in 2016, could we turn the learning goals that we had from BME Health Reach into a digital platform? And we were able to collaborate with the gaming company, Thrust Interactive, they're local in Atlanta, on an NIH grant, so National Institute of Health. It was a small business grant, so Thrust was the main player on the grant, and we were just a subcontract, and trying to look at how chronic illness situates itself well for STEM learning in a personal, meaningful context for the patients. And this is their flyer that they had for our previous game. The game is titled Hemonauts, and Thrust created a suite of games to help us answer the research questions. Can gameplay lead to increased STEM content knowledge, increased knowledge of intent to persist in STEM careers, and increased disease literacy to help patients improve with their self-advocacy? And in the spring of 2017, we were able to test the game with 20 pediatric patients, sickle cell disease patients that were roughly 10 to 13 years old. And this is the graphic of what the game looked like. The player would come in and pick their bot, and then they would pick a game that was in the body. What we did find is they enjoyed playing the game. They wanted to play more. There was some confusion about the setting of the game, of that it was their body. We wanted the patients to embody the bot, not the body. So we wanted to clear that up for the next version. It was very limited in its success as teaching STEM content. It was more about quizzing STEM content, um, so not great at that. But the patients really liked the game and they thought it would be useful to help talk to their friends about their illness. And it also opened our eyes to that there was a large deficit in just disease knowledge for the patients. So from those findings, we wanted to continue working on the game and revise it. So we have our Hemonauts version 2, which is what we're going to talk about the rest of today and the rest of this presentation. We received NIH phase 2 funding in August of 2018, and that's the big money. The whole goal of that is to get Thrust as a springboard for Thrust, so they can turn into the next Roblox or Minecraft or something similar. And we wanted to revise the game to increase the STEM content knowledge through gameplay. I'll talk more about that. And increase disease literacy, both for patients and then just for typical children. One of the researchers on the program is a computer science engineer, and she really wanted to look at how learning happens in games. So we added in components of looking at remedial education in different formats. And that's a lot of what I'm going to be talking about today is what is the optimal mode of delivery for STEM content within mixed media to promote an increase in STEM content knowledge. And mixed media is audio, digital, text, the graphics of the game. And I'll clarify that as we progress through. So for this presentation, following our learning objectives as outlined by HEAL, I hope that you're able to demonstrate knowledge of the digital games presented, compare and contrast how the presented game has provided value to the player, and define the game goals to increase disease literacy. And as I mentioned before, I have 2 slide decks for you. The first one is our informational slides, and then the game walkthrough. For this Hemonauts version 2, it was redesigned to teach STEM content related to the body. So the body would be the setting of the game, and the game designers really focused on making sure that there was no confusion between the characters and the body, because we didn't want the players to think that this game setting body could have all of these different illnesses at one time. Seems pretty morbid. In 2018, the game was developed, and here I have a cartoon of what the new graphics look like, and you can see it's a lot more colorful, a lot more kid-friendly, and just a different feel to it than the previous game. In the fall of 2019, we tested with typical school-age children, so 5th and 7th graders at our partner elementary and middle school, and that was twofold. One, to test the game for bugs, and then to help us answer that research question. And we wanted to test it with neurotypical children to make sure that we're doing a good job first before we introduced it into a pediatric population where we might have some deficits. And then the game was edited in spring 2020, and it's ready for testing right now. Unfortunately, as we all know, we hit a pandemic, so we weren't able to test the game with our pediatric patients, so we're just on hold for that till we can get to a better place with the pandemic. And as I mentioned before, we have the 2 different decks, slide decks for the game walkthrough. I wanted to show you the trailer for the Hemonauts game, and you can sign up for early access. And I also just wanted to restate that I have no conflict of interest or financial affiliation with Thrust or the Hemonauts.
Hemonauts,
For the game details, it has 4 levels, an introductory level, so you can learn how to play the game, move the game around. It's on a tablet, so you use your fingers to move across, kind of similar to Angry Birds, where you're dragging the bot through. There are 3 STEM-based health disease literacy levels. One that's called a blood blast, which is the circulatory system, sickle cell disease level, and then a diabetes level. And to get through all the levels of the game, it's roughly 8 to 10 hours of gameplay. After you get through the intro of the game, it asks you to name the body, and you can name it whatever you want. It does have filters on it, so you can't name it something awful. In this case, my son named the body Somebody. So if you see that as we go through it, that's the name of the body. So you get through your intro screen, and you can select from the Academy, Play, or My Lab. And here I selected on Academy, and it takes you to basically a glossary, and it tells you all of what the different pieces are and gives you some information if you click on them. And in this case, I'm going to click on platelets, and it tells you about platelets and what their function is, and then you can recognize what a platelet character looks like. If you go back to the home screen, you can click on My Lab, and in the My Lab is where you can kit up your robot. In this case, my son, again, made the robot look pretty funny. They have some free gear, and then you can purchase more gear with the collecting of the bolts, and that's what's along the top, that 800 or 8,337. That's the money that's been collected during gameplay. Just going back, if we hit play the game, this is what the home screen looks like, and you see we're on the training program, and there's the 10 levels. It has those golden pills, and that's just extra things that you can use in my lab, so different weapons and things that you might use in the game. There's the blood blast, the sickle cell, and the diabetes. So I selected on diabetes and started playing one of the levels, and this is where the game starts. You have at the bottom DD, which is your data dispatcher, and she gives you information about what you're seeing on the screen. Each of the rooms are locked until you open them, so you press on the H door that's on the right hand side of the screen once you've completed the action in the room. And then just one final image of the diabetes level. In this case, a needle is coming in and injecting the morning insulin shot. So it's a fun little graphic that the players can watch. Now, thinking of the education, so the game designers are really big on wanting to hide the education. And by hiding it, it means introducing it through gameplay. So thinking about how kids eat, and they don't like to eat spinach, so you hide the spinach, you chocolate coat the spinach, the same sort of thing. And the way that the game does this is it introduces it through gameplay the first time. So in this case, the player doesn't have to interact. Everything happens for the player. The player is a butterfly bot, and it comes into this room, and it sees that there's a wound at the bottom. There's some bacteria guys that are coming up, and then there's the little hard hat platelets that come down, and they clot the wound. They put up these little construction cones. You can see that no more bacteria are coming out of the wound. And what you'll also notice is that previously the right-hand door had a lock symbol on it, and now it is unlocked, so the player can move on to the next room. Later on in the game, the player will encounter a similar scenario, but this time the platelets are locked behind these crates, and they've learned from the intro level that they can break the crates by ramming into them. So the player should recognize that they need to break the crates to free the platelets to clot the wound, and then the door will open up. So that's how the education is taught through gameplay. In the fall of 2019, we did our 10-week study with roughly 200 fifth and seventh graders local area schools. They completed a pre and a post survey on the STEM content related to what was in the game. They participated in 6 45-minute sessions, and during those sessions, they played the game, and then there was small and large group feedback sessions. And we have quantitative and qualitative results, which I'm going to share with you today. Again, going back to our research question, so what is the optimal mode of delivery for STEM educational content with immersive, interactive digital media to promote an increase in content knowledge? Basically, what's the best way that the players learn? And this is a topic for the computer scientists and in the education field related to digital games, of how can you teach players, students in the best possible way. So we had 4 conditions for what we called remediation, and I have an example of what remediation looks like. So in that, the player would either get the digital graphics with text, the digital graphics with audio, the digital graphics with text and audio, or our control where they would have no remediation. And based off of the educational literature, it was decided that our hypothesis would be that remediation of graphic and text would provide the most knowledge and highest post-survey scores as compared to the pre-scores. And so what do I mean when I talk about remediation? So previously, we saw that the educational material was introduced through gameplay, and this is for every player. Next, then the player needs to recognize and display what they have learned to get through the challenge. And then when it gets to remediation, we have what we called an in-game challenge or a puzzle. And in this case, the player encounters a different looking setting. There's a wound that they found, and they have been told that they need to seal the wound. So they are now given a choice, and they need to choose, in this case, between a red blood cell, a deoxygenated red blood cell, and a platelet. So what we did here is we ended up selecting the red blood cells, and it doesn't clot the wound. The red blood cells keep going out of the wound. So the remediation is that the data dispatcher puts up text that they made the wrong choice. They need to pick something that can seal the wound. And then there's also the accompanying audio to the text. So the player is then put back into the beginning where they're given, they need to make a choice. They choose platelets in this case. The platelets go and seal the wound, and they are able to move on through the game. And the data dispatcher tells them that they've done a good job. They selected the correct item. So this is what we are talking about with our remediation, that they've gotten to this puzzle level and this in-game challenge, and if they get it incorrect, they get remedial information so they can make the correct choice. Testing with our kids in the fall, we tried to do an even job with giving all of the different remediation options. It was randomly selected, so you can see our pie graphs of it was pretty good, of a quarter per each of the conditions. For the questionnaires, there was obviously our pre and our post, and there were 6 questions that were related to blood composition and blood cell function, 5 questions related to blood vessel function and the physical characteristics, 3 questions related to sickle cell disease, and 2 questions related to diabetes. And of these 16 questions, 6 of them were directly related to the remediation puzzles. And an example question that I had for you was, what kind of blood vessel is larger? And the players would select between veins, capillaries, and no answer. We wanted to have the no answer so that they wouldn't just guess, and that would compound our results. What we did find was that there was statistically significant learning gains for all of the conditions. All of the scores improved for pre and post, and there was no difference between the remediation types, and I'll get into that in the next few slides. And that was pretty interesting to see because it didn't fit with our hypothesis and fit with the literature, but it does show to us that the education was taught very well to the players through the gameplay. So that's a really cool thing to see. And it was an effective tool at teaching the STEM concepts. For our results, we did statistical analysis on our pre and post questionnaires. We had a t-test, which was paired for 2 sample means, looking at the different remediations. And for all cases, for both of the schools, the test scores improved with statistical significance in all remediation types. And then we looked at a binomial statistical test to determine the statistical significance between the pre-correct versus post-correct scores of all of the questions, and all of them showed statistical improvement. So again, the players learned from the game, and the game did a really good job of teaching through gameplay. Looking at our 5th graders, these are the 10 questions that were not related to the remediation puzzles. We have our pre-scores in yellow and our post-scores in blue, and you can see the improvement for all of these questions. And if you want to get what these questions are, the surveys, I'm more than welcome to share them with you. Just send me an email. The similar results were found for our 7th graders. The pre is in green and the post is in purple. Significant improvement for all of the questions, so they learn through the game. Now looking at the remediation and the 6 specific questions that related to the remediation puzzles. Those 6 questions are graphed here. Again, pre is in yellow, post is in blue. The ones with the stars showed statistical significance between the pre and the post, and that was a question about hydration, veins, capillaries, and our platelets. Looking at the 2 that didn't show statistical significance, our first one was related to hydration. It was another question. It asked them, does staying hydrated make you feel energized? And the percentage correct only increased from 81 to 84, so not significant. The other question was related to insulin, and it decreased from 61 to 59%. So obviously the gameplay didn't impact, or the remediation didn't impact the learning in this case. I will say that the players spent the least amount of time in the diabetes level, so that might be part of our reason why. And we're hoping when we're able to test with the patients that they'll be able to spend more time in all of these layers. They'll have the game on their own personal devices for a whole month, so hopefully they can get through the game more than we were able to with the school-age children. For the 7th graders, again, we have our pre in green and our post in purple. The 3 questions related to capillaries, platelets, and insulin showed statistical significance and improvement from the post scores. Those are the ones that have the star on them. And then the ones that didn't show or didn't have statistical significance, we'll walk through those. The first one was related to hydration. Hydration makes your blood flow faster, and it only increased from 89 to 94%, so not significant, but improvement. The second question again was hydration makes you feel energized, and the percentage did increase from 88 to 89, but not significant, so there was some learning gains there. And then the third one for the 7th graders was related to the function of veins, and there was no change in the pre and post correct responses. So the content was either not understood through the game or they already knew the information. Obviously, we need to do a better job with these topics. Now, looking at our qualitative results, we had questions to the players afterwards and then some post-written responses. Overall, the 5th graders were more positive in their attitudes toward the game. They enjoyed their time more. They wanted to play it more. The seventh graders were a little more negative. When we asked them, did they think it was a good way to learn about the body? About 10% of the seventh graders responded negatively, saying they didn't learn much, the information probably wouldn't stick. Only about 5% of the fifth graders responded negatively. It was much more resounding positive experience for the fifth graders. The seventh graders kind of always said it was boring, wasn't super interested, didn't draw my attention. They found it repetitive and that it was boring. And the fifth graders didn't have that same complaint. So I think it's safe to say that this game is probably suited for that younger age group, that 10 to 11-year-olds. Um, but we need to continue testing the game. In conclusion, Hemonauts was successful in its goal of increasing STEM content knowledge and disease literacy through gameplay. We were surprised that the incorporation of remediation to improve learning outcomes didn't appear to have an impact regardless of the type of remediation. That's a big topic for the educational gaming community, and we're working on a paper related to that. The use of game mechanics to communicate metaphors was successful in achieving positive learning outcomes. So for the game designers, they hid the spinach really well, which is exciting to see. And we hope that our future research will include our chronically ill patient populations. We really want to start that testing. The next steps for the game are to revise it based on our presented results, which has been done. When we test with the pediatric patients, the remediation will automatically be given as text and audio. We're not going to look at the different types of remediation. We do want to see how successful they are through their gameplay. We have gotten our IRB approval, but now we are on hold due to the pandemic and funding related issues. So hopefully we'll be able to get that up and running soon. And again, just a reminder that if you want to go be a playtester, you can, and I have no conflict of interest. And our acknowledgments. You can email me if you have any questions since there's no live Q&A, and go check out the second slide deck that has the game walkthrough. And thank you for your time. Hope you have a great day. Bye.